Good morning, Year 4. How are you? And welcome to your maths lesson for today. Today we are going to be counting in fractions, but before we learn about that today, I have some daily fluency questions for you. There are just 4 questions here. Can you spend no more than 4 minutes answering them, please? Pause the video here, write your answers down on a sheet of paper underneath your date and title for today, please. Okay, number 1, what is 5/9 add 7/9? So if we add 5 and 7 together, we get 12/9. In number 2, how many holes are there? Well, we can see that each bar is split into 5. 3 of those bars are full. They are all shaded in blue, therefore there are 3 holes. Number 3, well, if we are finding their difference in the area, we can count the first shape and see that there are 6 squares, and the second shape is 7 squares. The difference between 6 and 7 is 1. And finally, rounding 472 to the nearest 100, we can look at our tens and see that it's a 7, so that means we need to round up to 500. Well done if you got all of those correct. I do have some more fluency questions just for you to recap before we start today's lesson, and this will help you with your learning for today. So look at the following number lines. For question 1, what's the same about them? What's different? And number 2, fill in the missing fractions. So if you just pause the video here, write these answers down on your page 2, please. Off you go. Okay, well, you might notice what's similar about these number lines, that there are 4, they've been split into 4 sections, but what's different is that the first number line goes from 0 to 1 and the second number line goes from 0 to 2. So the jumps, the fractions that are going to be represented by each line are going to be different in each number line. I wonder if you remembered or had a go at filling in the missing gaps. So if we're going from 0 to 1, we know that the first would be 1/4 because we've got four sections and this is the first one. The second one would be 2/4, then it would be 3/4, and then it would be 1, which is the same as 4/4. For number 2 then, that goes from 0 to 2, it would be 1/2, 1 and 1.5, then 2. For number 2, we are counting up in 1/7. 1/7. So we've got 1/7, 2/7. What comes next? 3/7, 4/7, 5/7, 6/7, 7/7, which is the same as 1, and then 8/7. And I wonder if you can turn this into a fraction, which would be 1 and 1/7. So well done. Now, today we are going to be thinking more about how we can convert improper fractions. So we're going to have a go at using the part-whole model to help us. So we have got some bars here. In my first section of my part-whole model, I have got 2 bars. Can you see how many each bar has been split into? What would the fraction be? That's right, we have got 1, 2, 3, 4, 5, 6 parts, and 6 of them have been used. So we have got 6/6, which is the same as 1 whole. And then in my second bar, we have got another 6/6, which is the same as another whole. So altogether for this section, we have got 12/6, and we can see that that is the same as how many holes? 2 holes. Fantastic. And in the second part of my bar model, I can see that I do not have a full bar. I only have 2 out of those 6 that are shaded in. So this fraction represents 2/6. Now, if I have 12/6 add 2/6, how many 6 do I have altogether? That's right, I have 14/6 altogether. Now, if I wanted to convert this, then that would mean I have 2 holes and 2/6, and that would be my fraction. We're going to work backwards this time. We have been given our answer, which is 18/5. Now, we need to work out how many holes there are and how many other parts there are. So, we're going to think, well, we have a bar model. How many is it going to be split into this time? What's our denominator? That's right, it's going to be split into 5, and that is going to be 1 whole. That is going to be the same as 5/5. So that means we need another whole. So this time we've added another 5/5. How many fifths do we have now represented in this section of my part-whole model? That's right, we have 10/5 represented so far. So we need to add another whole in, which would be 15/5, which is the same as how many holes? 3 wholes. Super. We know then that we've got 3/5 left over because to get from 15 to 18 we add 3. So we have 3/5 left over, which is the same as 18. And if we wanted to convert this, how many wholes and how many fractions would we have? That's right, we would have 3 wholes and 3/5. Super job. Now, today's aim of the lesson is to count in fractions. So we need to work out what the next number in this number line would be. But to do that, we need to work the difference between 4/6 and 5/6. How many sixths are we counting in? That's right, we're counting in 1/6. So each time we are adding on 1/6. So 5/6 add 1/6 would be 6/6. Add another 6 would be 7/6. 8/6, 9/6, and so on until you get to 19/6. Now, we know that some of these fractions are larger than 1 because we know that in this case 1 is our 6/6, isn't it? That is our whole. We need to know what the next fraction would be after our 1. Now, we can use bar models to help us because the first representation here shows 4/6. We have 6 altogether, 4 are shaded. Similarly, we have 5/6. And then when we get to 6/6, we notice what? What is different about this model now? That's right, it's full. It represents 1 whole, so that is our 1. So that means for 7/6 we need 1 whole and 1/6. And for 8/6 we need 1 whole and 2/6. For 9/6 we need 1 whole and 3/6, and so on. So we have got to 12/6. Now what is different? Is it going to be 1 whole and 6/6? Or what is going to change? Pause the video and have a think. Did you get it right? Did you notice that 12/6 is the same as 2 wholes? So it's going to be 2. And then 13/6 would be 2 wholes and 1/6. All the way up to 18/6. Now I've stopped at 18/6 because what would 18/6 be? That's right, 18/6 would be 3 wholes, which is 3, and 19/6 would be 3 wholes and 1/6. So we have just shown there how we can count in fractions by adding a 6 each time, but how we can also convert them into our mixed fractions too. So well done. Now, I've got another number line here for you, but this time it's not jumping up in 1/8. We need to find out what it's jumping up in. So it goes from 1/8 to 4/8. What is the jump? How many 8s are we jumping up? Pause the video and have a think. Okay, did you get it right? We are jumping up in 3/8. So 4/8 add 3/8 will be 5, 6, 7 8s. Then 7/8 add 3/8 would be 10/8. Can you work out the rest of the sequence, adding 3/8 each time? Pause the video and have a think. How did you do? Did you find 13/8, 16/8, and 19/8? Now, are any of these fractions larger than 1? Can you point to them on your screen? That's right, you might have noticed that 10/8, 13/8, 16/8, and 19/8 are all larger than 1. They are called improper fractions, when the numerator, the number on top, is larger than the denominator, and we need to change that, and we need to make sure that we are converting them into our mixed fractions. We can use our part-whole model to help us. How many wholes would we make? Well, we would make 1 whole because we've got 8 8s. How many do we have left over? We have 2 8s left over. So 10 8s would be the same as 1 and 2 8s. Let's see if we can do 13 8s together. Then I'm going to ask you to work out what 16 8s and 19 8s is. So 13 8s, how many wholes do we have? How many times does 8 go into 13? Just the once, well done. And how do we get from 8 to 13? 9, 10, 11, 12, 13. 5 remaining, so 5 8s are left over. So 13 8s is the same as 1 whole and 5 8s. Can you work out 16 8s and 19 8s? Pause the video here and off you go. Okay, how did you get on? So 16 8s, we know that it's actually got 2 wholes making 16 8s. So it would just be 2. 19 8s, we can see that there are 2 wholes making 16 8s. and 3 wholes left over, so it would be 2 3/8. What I would like you to do now is have a go at questions 1 and 2 on the worksheet. Pause the video, and then when you've done that, head over to part 2 of the video where we will be completing the rest of the lesson.